This is my webcast of Python Before Eggs, a kind of land before time style presentation that I gave at the Python Atlanta meetup in January 2008. It's about what the Python language was like before egg package files were invented. I was kicking off our meeting by providing background for the three big talks that followed. I'm Brandon Craig Rhodes. Which came first, the Python or the egg? The answer is that not only did Python come first, it came first by 12 years. Python survived without a good packaging technology for more than a decade, in contrast to something like Java, which I think supported the idea of jar files right out of the box. Before our talks this evening on three Python technologies, eggs, virtualenv, and buildout, that all have to do with packages, we need to think about where do Python modules come from? I mean, from where on your hard drive does Python load modules when it encounters an import statement? Now, modules, unlike eggs, were an original feature of Python. The idea was that rather than having to stuff all of your code into a single file, you could, as in this example, place two useful mathematical functions in mymath.py, and then say import mymath everywhere else in your code that you wanted to use them. So where does import look when you give it the name of a module? Well, first, as we just saw, it looks in the current directory, which makes it easy to break programs into convenient pieces by writing more .py files. It also goes looking in its own install directory, where it keeps the standard library, all of those hundreds of included modules that let us brag that Python comes with batteries included. Here are some places that it lives on some systems I looked at. So that's the second place import looks. Finally, what about third-party modules? When you download a Python package off of somebody's website and install it, where does that get placed? Well, in ancient times, you often had to copy third-party modules into one of the two locations we've already looked at. The current directory, where only the one program you're working on could find it, or the main Python install directory if you wanted it available system-wide. The result was a mess. Months later, you'd find yourself asking, which of these modules came with Python? Which were from other vendors? That was a big deal if you were upgrading to a new version of Python and needed to reinstall all of the third-party modules you'd grown to rely upon. So, with Python 1.5, back in 98, a third module location was introduced, a directory called site packages. It sits inside of the system-wide package directory to hold third-party modules and keep them separate from the standard library that came with Python. So returning to our question, we'll now find we've completed the answer. Import looks in the current directory. Failing that, in Python's own install directory. Failing that, it looks inside of site packages. Now what happens when things go wrong? When you import a package and it looks like it's an older version than the one you think you just installed, or when Python can't find a module at all? Well, I have good news. When importing modules, you don't have to guess about what Python is doing, because you can always ask Python where it's looking for modules. How do you ask? Here are three techniques, and note that these techniques will work regardless of which advanced technology we discuss later this evening you might want to use. Technique number 1. Import the module and examine under file. Under file is a string that Python places in every module you import to tell you what file it was read from. Here are two examples. The OS module says that it lives in the standard library directory on my system, while the LDAP module admits that it's a third-party module sitting inside of site packages. Looking at under file can be really useful, but of course it only works for modules that you can already import successfully. So technique number 2 is more general. Look at the value of sys.path. This works even if you can't successfully import the module yet, or if you're confused about why you're getting another version of a module than you think you should. Sys.path is a list of strings that name in order the directories that Python will search when you do an import. Here's an example. I know, I said that Python looked for modules in only 3 locations, and here I am showing you a sys.path with 11 entries. But if you'll look closely, I think you'll see that they fall out into roughly the 3 categories I listed earlier. The current directory is listed first, that's the empty string. Then comes the standard library, split up among several locations on my system, but all living under userlib Python 2.4. And my particular system has several site package directories, as well as a special area where Debian installs things. Anyway, by asking Python for this list, you can check whether a directory is missing in which you've just installed a new package, or whether the directories are in the wrong order to get the version of a package that you need. Finally, if all else fails, we pull out the big guns, technique number 3, trace the program's execution. All reasonable operating systems, I've listed their names here, provide an easy way to track all of the system resources that a program touches during its execution. Through tracing, you can see every file and directory that Python is searching during your import statements. And so you can see every error when Python can't open a file, whether a directory doesn't exist, or a file's missing, or something's there but it's not set readable. Here's an example. I'm running the simple one-line Python script import OS right on the command line and asking Linux to trace the program and deposit the trace in the text file trace.out. I then view the hundreds of lines of trace output looking for lines that mention the OS module and find several lines together which show me Python's successful attempt to import the module. Let me add some syntax highlighting here to make it easier to parse. Here we see that for every directory in sys.path, Python is actually testing 5 different file names to see whether they exist. First, it searches in python24.zip, which doesn't even exist on my system, for 5 different files that could contain the OS module, and finds nothing. Only when it then turns to the plain python2.4 directory does it find some files, and receives file descriptor numbers, 5 and 6 in this case, instead of no such file or directory errors. By looking through this kind of detailed output, you can finally find out exactly what Python's doing, whether it's looking in the right place to find a module you've installed, and whether it's encountering an error when it does. So, as we now head into our 3 main presentations, what are the main problems with Python package administration, done the old way? Because each of the solutions you'll hear about tonight tries to address some or all of these 4 problems. 1. You needed administrator access to install packages if they're all going to live in a system-wide folder. 2. It's hard to automate the installation and removal of packages if you're putting them in site packages one at a time. It can really be a pain if you're installing something with 5 dependencies that you have to go download and install them as well. 3rd, with only a single site packages directory, you can't have 2 versions of a third-party package installed at once. You're either going to have, I don't know, either the LDAP module version 2 installed or the LDAP module version 3 installed, but you can't have both. 4. Because of this, an upgrade necessary for one Python app on your system can break a dependency for another. This is a huge headache on production systems that customers are using. If you upgrade the LDAP library to version 3 for a new application, the next minute you can be fielding phone calls from customers wondering why their website is suddenly returning errors. Because, unbeknownst to you, the previous maintainer's web scripts were only compatible with version 2 of the LDAP module. Each of the following talks tonight is about a solution. First, we'll hear about eggs from Jeremy Jones. Then virtualenv will be covered by Noah Gift. And finally, I'll return to discuss the many splendors of buildout. Thank you very much. Picture of the egg carton on slides 4 and 5, courtesy of Gabe Photos on Flickr.